Hello, I'm Dr. Alicia Stowe, the lead R&D scientist with CEM Corporation. The University of Almeria in Spain has kindly shared this presentation with me, and I found it really exciting. So I thought this was a great opportunity to add my commentary to their presentation. So please note, these are not my slides. Simply, I'm going to add my opinion of the slides that they presented recently. So with that, the title of this talk is Coffee and Cocoa Analysis by Automated Extraction based on PLE, which is Pressurized Liquid Extraction. So they jump into this conundrum of sample hydration, right? Do you need it? Do you not? Because there's some pros and cons to sample hydration. And current methods often recommend to hydrate the samples. But as noted, there's pros and cons to that. So the hydration can increase extraction of polar compounds, but at the same time can hinder the extraction of some apolar compounds. And then also there could be some co-extraction of other matrix components that could lead to some issues as well. So again, to continue on, when you add water to hydrate an extraction sample, you then have to remove that water later on. So that can add complexity to the situation. However, the only way really around adding water is to use an energetic extraction conditions that can basically overtake the benefits of that water and lead to accurate extractions without the use of water. And in general, that's not been available for labs in today's world. However, there is a solution out there, and that's what we're going to be talking about or discussing in this presentation, which is a high energetic extraction with organic solvents, which essentially is automated pressurized liquid extraction and heating. Now, automated extraction is gaining popularity in today's world, and I think that is kind of expected, right? With more technology, there's more automation available, and we're going to be implementing that more in our labs. So I think this just generally is an expected trend, and it will continue to increase as more automation is available to us in our labs. So I think it's just exciting to be in the forefront of such modern technology in our labs and being able to add this automation beyond just extraction, but to sample preparation as a whole. I find exciting because we really haven't seen too much as far as automation in the world of sample preparation and extraction. So, but there are some out there, okay? As I noted, it's gaining interest, and anything that's gaining interest, you're going to start seeing products on the market, and automated shakers have definitely gained in popularity, and you definitely are seeing those more and more in our labs. And there's also some automation out there for automating the catcher's method. Really these are kind of like more robotic systems that are doing all the different steps of the catcher's process, and they certainly exist out there on the market. But what we're going to be exploring in this talk is another type of pressurized fluid extraction that is a different take at this for extraction samples. This video here is going to walk us through the software of the CEM Edge system, which does the pressurized fluid extraction. So you saw you enter into your menu, and at the top you have settings. And so this is just walking you through the different types of settings on the system level, where you can choose your language. For instance, this talk was done in Spain, so they were probably using Spanish. You can just set your date and time. You can set your run settings, and this one is probably where you have the most control over the visual of how you want your samples to appear and how you want them to run. So if you want all of your samples to be labeled in a certain way, and the number that you want them to be, and then the batch size is important. The rack on the edge has 12 samples in it, so you can run 12 at a time. However, you can program up to 24. So it will just ding, and then you pull one rack out and slide the other one in. Your preferred QDIS setting, there's a lot of different QDIS options. However, we recommend our S1 as our universal QDIS. You can preheat or not preheat, have audio indicators, liquid sensor, a lot of other different things that you have control of in the settings here. for how that run will take place on the edge. Now, solvent is important, and we have a lot of preloaded solvents already on the system. However, if you needed to, say, add a modifier of formic acid or acetic acid at a certain percent, you can make that note and add your own solvent. So here's this where you would add a solvent, and that is up to you. The edge is compatible with pretty much any organic or aqueous solvent. And then our bottle setup. There are 6 solvent lines on the edge, so you can program up to 6. It is important that these are programmed properly because that is what is going to be added in your sample for the extraction and what is going to be recorded on your report. So you want to make sure that that is done properly. So that was our settings. Now we're going to go to our tools. This is more from a service perspective to make sure that everything is running properly and you have control over the different components. Here you're turning the lights on and off, you can turn the fans on and off. Pretty much you have control of the different components within the system. Here, if you needed to test them for any reason, here are your auto sampler controls just to make sure that they're all working as they should. In our utility section, you have a number of different options from prepare to ship, a clog check, prime solvent lines, system purge, system wash, and all of these things you would need to do just for checks to make sure the system is running properly and as it should be, or if, for priming lines, when you switch solvents, you come here and prime those lines. So that's a pretty important one that we're showing here. Another thing is our Q-disc on the edge. As noted, we recommend our S1 as our universal Q-disc, but you see that there are a lot of options here. Q-disc can be scanned in and or you could type in a barcode. They are counted, so you do need to add Q-disc to be able to load them to your method and run your extractions. So I think they're going to show you the barcode scanner here, but if for any reason you misplace that or don't have access to it, you can type in your barcode. Please note that these barcodes are case sensitive, make sure if it's a capital letter, you type in that capital letter. But overall, you add in your Q-disc, and then when you are running low, the system will alert you so that you make sure you add in more Q-disc. Calibrations, you can calibrate the temperature, the pressure, and the auto sampler. However, once calibrated, they stay calibrated, so you really don't have to worry about that. And the system update is just when you are updating software. On the users section, this is where you have control over the different users and controls. So you can have an administrator that can have full access to things, or you can have other users that cannot, say, make method changes or so forth. We are ISO compliant, so we're making sure that you can set up the controls for your lab for the different users that is going to work best for your lab. This video is going to show you the different accessories that are used on the CEM Edge system. So first here we're looking at our Q-cup, which is the sample holder. Okay, it is 2 pieces. The bottom easily turns on with just one thread, and it's just a hand-tight method. So you saw how simple that was to put that bottom on and off. In between those 2 pieces, you do put your Q-disc. That is going to enable your filtration. Our recommended Q-disc is S1. S stands for stack of Q-disc, so it actually is 3, as you just saw represented there. It is in the center a G1, which is a glass fiber Q-disc, and on the outsides are C9, which is a cellulose Q-disc. The G1 filters down to 0.3 microns, and the cellulose discs just kind of are there to keep that G1 integrity and in place. So now we're showing the individual components because you can run just one. You don't have to use that stack, although it is recommended. The C9, again, that's a cellulose 40 micron, and then the G1 is a glass fiber, and you can visually see the difference that Q-disc is a different type of material. And then we do have other Q-discs. This is showing our M2, which is a PTFE with a polyethylene scrim, and just to show we have some variety of different materials and different filtration options. But this is our S1, which we highly recommend for all applications. It comes in this packaging pre-stacked, so it's easy to use and easy to put into that Q-cup. Now, the University of Almeria uses a lot of sand in their application, so they're showing that. So that is just a commodity that is good to have in your lab. This is our Q screen. It is a stainless steel mesh, and you see the tool that you use to put it in. I think they're going to show you how that works here. So you just insert the Q screen to the top of the Q cup, then you use the tool to push it down into the Q cup. And you also use the tool to remove it from the Q cup when you're cleaning post-extraction. The Q screen is just a good tool to keep everything compact and into the cell in the way that you want it to for just proper running. We recommend the Q screen for almost all applications. You saw your collection options back there. You can collect in a vial or a centrifuge tube. On vials, we have a variety of options from amber to clear to graduated, and different volume options from 40 to 60 mils. And then the edge is compatible with your standard 50 mil centrifuge tube. So that's what you'd use in collection. And that kind of covers it. Not a lot of accessories. You don't have a lot of consumables. They're really easy, come together very quickly. So this video is going to walk you through preparing a sample to run on the CEM edge extraction system. The first thing you're going to want to do is prepare your Q cup. So you take your S1 Q disc, put it in the bottom of that cap, and then assemble your Q cup. These are just some different materials that you may or may not use. Luminex is for washing the Q disc, Q matrix hydro is for removing water, and then sand may be used. In this case, they're going to use a tea sample, which you see prepared there, and sand. So you would put the tea into the Q cup, the sand, and then drop that Q cup in the rack as you saw here. And you must have a collection tube as well. So, and make sure that collection tube does not have a cap on it. So now that you've got your Q cup with your Q disc and your sample, in this case it is tea with sand on top, which you saw pictured there, and it is loaded in the rack, you then load that rack onto the edge system. So the rack is held in by magnets and it slides into place. You do want it to be flat, so you'll see how that's kind of up a little bit in the front. You'll see them adjust it just quickly and see how it clicks down, and then you know you're in the right spot and the magnets hold it in place. Once you have loaded your rack onto the system, you just have to tell the system that it's ready to run. So you choose your method, the position that is in the rack that you want to run, and you hit start, and then the system will take over from there and do the extraction. In this video, we're going to talk you through setting up a method on the edge. On the edge, you have two different types of methods, one-touch methods and users methods. Now, the one-touch methods are pre-programmed at CEM. However, in most cases, you're going to want to use that as a template and then make edits to adjust to your particular application. Once you copy that method, it will show up in the users method, where then you can make your edits. You can also make a method from scratch. If you create a new method, you just hit the plus symbol at the top there, and then you can choose the name of that method. In this case, I believe they're just going to call it training. After you have named your method, you can choose your Q disc. We recommend S1 as our universal Q disc, and we'll get to the collection in just a little bit. We're now going to move over to the cycles. You can see all of the parameters here, make changes here, or you can click that edit icon to do it in this frame. You would then choose your solvent and you choose the volume that you want to add. You can add from both bottom and top. However, we recommend for most applications to do a top add only. Once you have chosen that, you then can choose your rinse solvent if desired. Now, a rinse is just going to add after the initial collection of the extract and rinse through and collect in the same vial. So most cases, you're going to want to use the same solvent in the rinse as you used for the extraction. You choose your rinse time and then your temperature and the whole time that you want to be at that temperature. There's also an option for bubbling. If you do choose to turn bubbling on, you can then add the amount of time that you would like to bubble for. The bubbling occurs prior to heating. In this case, we're not going to use any bubbling for the method. So it just shows you how easy it is to edit these volumes back and forth. You just click and then you get the keypad turn up so that you can make changes. If you wanted to, you can also add multiple cycles as well. You can add up to 12 cycles. And once we add another cycle, you get an option of standard or rinse. A rinse only cycle is going to be exactly that, rinse only. So it will only add solvent and then collect that solvent. So you only have to choose the solvent and the volume of that solvent for that particular cycle. If you did a standard cycle, you have all the controls such as temperature and hold time that you can edit as well. Once you have added your cycles, you then want to go and set your wash parameters. And this is just showing you can edit from either perspective. Once we're in the wash, again, you're going to want to choose the solvent that you want to wash with. In a lot of cases, this will often be the extraction solvent, but you could choose something different as well. The volume that you want to wash, and then the hold time and temperature for that wash. So you don't have to add temperature or hold time, but we do find that holding a wash for a little bit of time at temperature aids for better washing. And you can do multiple washes as well. And the same thing with the washes, you can click that edit icon and get this screen if that is favorable for how you want to program your wash. Now, if we go back up to settings, you'll see collection. You can see that you can do a combined or separate. In combined, everything will be collected in one centrifuge tube and vial, or separate is going to collect the different cycles separately. Once you have saved your method, you then select it. You can choose information for any methods that have run before, and it will show you how many times that method was run, the name of that method, and then give you the run details of that method. You can see in graph format or in table format to know a specific time, and whatever temperature and pressure was at that time will tell you that. So you have complete control or information regarding all the methods that have been run on the system. If you wanted to run a method, you simply click it, and then you choose what positions in the rack that your sample cell you want to run that method on is located on. You hit play. At this point, you can choose your sample ID if you wanted to name it any differently or to track that in any sort of way. So we're just adding a sample ID here. You can add a sample ID for all of the methods queued up at this time if you so desired, and then you hit start and it is going to run the method that you have set to run. And that is how you would run a method on the edge. In this video, you're going to see an actual sample run on the edge. So after we've loaded our rack with our samples, we are then going to pick the method that we want to run our samples on and choose which positions in the rack those samples are located. Once we choose that, we hit play, and now we're going to add the sample ID to identify the samples we have loaded. So we've got position 1, which has a T sample. Position 3 is going to have a cocoa sample in it. Position 4 is going to have a olive sample on. So we've got some varying different sample types here. And then position 5, we're going to run solvent only. So now that those methods have been identified, we are going to hit start, and the edge will take over and run those extractions. Once we hit start, the first thing that's going to occur is it's going to load the Q cup containing our sample into that back chamber so the extraction can take place. The edge does run in series, one right after the other. So you'll see it pick up the Q cup and load it into that back chamber. Once it loads it into that back chamber, the actuator is going to come down. That actuator is fitted with 2 O-rings that seal both the cup and the chamber so that we're now working in a sealed environment where we can heat and pressurize. The automation is serving dual purpose. It is used to obviously load and unload the samples, but if you see there, we also have our dispense needle. So that dispense needle is going to position itself directly on top of our centrifuge tube, and that is where the collection for the extract will take place. And as noted, that actuator is now down. Now, at this point, the next stage is going to be adding the solvent. So the solvent is going to add into that chamber. Once the solvent has added into the chamber, if you choose, bubbling will take place at that point. If you have chosen not to do bubbling, it then will start heating and in pressurizing. Those kind of happen together. As we heat hotter, more pressure is built up, and you see that you have complete visual at all times on what is going on, what temperature and pressure your sample is currently at. And once it reaches temperature, it then goes into the hold time for whatever was programmed. You can also click the graph button if you wanted to see this in graphical form instead of looking at the graphic of the cross section of the Q cup. So you have a couple different visuals. You can also see what samples are loading, what's coming next in the queue. Once your hold time is reached, the sample will then move to collection. And we're about to just hit there. Now I did, everything here is happening in real time. We did speed up a little bit there during the hold time, just so we weren't sitting here for the whole few minutes that it was holding at. But once we get to collection, you'll see it first. Collection is 2 stages. Kind of use the back pressure in the system to collect the initial volume, but then a pump is going to turn on and purge any last little bit of solvent in. Now, if you, in the method we're running here, we also have a rinse, so there'll be initial collection of what was heated and held at a temperature, and then it will add more solvent, run through that sample and collect that. So you see a couple different stages of collection occurring. And then this is kind of showing you back that the software is telling you at any moment in time what is occurring. So in this case, we're currently purging. If it's during the purging process, then most likely the pump is on, purging your extract into your centrifuge tube. Please note that an extract is going through a cooling coil and a filter. So what is collected at the end is cooled and ready to go for analysis. Now you'll see the system is venting. And then once the venting has occurred, then it is actually showing the second cycle occurring here. So if you had a 2-cycle method, it's just going to repeat everything we just said for whatever was programmed in for the second cycle and collect that as well. You can do up to 12 cycles on the edge, so you have a lot of flexibility. In this case, this was a combined collection, so everything was collected in the same centrifuge tube. However, if you so desired, you could do a separate collection as well and collect in multiple centrifuge tubes. That's all however you've programmed your method. Once the extract is done, the next step is to move on to washing. So what you'll see occur here is we need to remove the sample from the chamber so that we have that entire fluidic pathway that just saw your extract available to be washed. And so that's what it's doing here. That actuator is going to open up. That automation is going to go and pick up that Q cup that's now our extracted sample, and it's going to return it to the position that we are in. And the extract at this point is done. So that extract, like I noted, is cooled and filtered and ready to go to analysis. So you see nice clear extract. This was tea. So here's our tea extract. And that is, like I said, ready to go for analysis. You'll see the system there returning that Q cup in the back. Once the Q cup has returned, the automation also performs the washing. So that same dispense needle, so what just dispensed your extract, is going to move over to our waste port, which is in that back right, and wash the entire fluidic pathway. So you'll see now the system is telling you that it is washing. It's going to do whatever wash parameters that was programmed in. Once it has completed that washing, it would move on to our next sample, in this case, the cocoa, and so forth. So hopefully that gave you a good visual of how the edge runs the extraction. When using the edge for automated extraction, it lends itself well to doing a lot of method optimization. So if you are in an R&D environment or have a challenging sample, you can quickly change a few factors and really tune the method to your needs. In this slide, it shows some of the factors that they looked at when optimizing the methods for the University of Almeria. And you'll see they did a lot of different solvent options. They tried some with bubbling, some without bubbling. They utilized some different hold times. Sometimes they did a rinse, sometimes they didn't. And there's just a lot of flexibility here. And you can do this all very quickly. You can set up 12 different methods in the rack and run them back to back. And so in a matter of hours, you really have significant feedback on what's going to be the best method for your samples. Here we have the extraction and for GC amenable pesticides. They've covered a wide variety of pesticides, both GC and LC, and this is just a really nice representation of the workflow. So they started with a 4-gram sample. They extracted that in 10 mils of acetonitrile. They used an edge method where they held for 150 seconds at 40 degrees C. That was collected, and then an additional 5 mils of acetonitrile was added and then collected. That entire process, the extraction, took around 7 minutes of time. They then evaporated 50 microliters of the extract and dissolved that in a GC amenable solvent, and then went to GC MS analysis. So as you can see there noted, up to 70 samples in an 8-hour time frame. So that's some pretty good throughput. And keep in mind, a lot of that time was automation. So that technician was free, able to do other stuff during that time. For the LC amenable pesticides, a very similar process took place. 4 grams of sample and 10 mils of acetonitrile, so no difference there. The same edge method was used, held at 150 seconds at 40 degrees C, and then a rinse of 5 mils of acetonitrile. So again, 7 minutes total for the extraction. In this case, they diluted 1:4 ratio with water and then went direct to LC-MS analysis. So since the extraction time was the same, we gained the same throughput for the LC amenable pesticides as well. So in total, the University of Almeria looked at 363 pesticides that were both GC and LC amenable, kind of a 50-50 ratio, a little bit more LC than GC, but a wide range for both LC and GC amenable pesticides that they were able to look at a couple different concentration ranges as well. So now let's take a look at the data. Over 90% of the compounds were successfully validated with acceptable RSD values. So we're seeing a lot of green in these particular graphs for both cocoa and coffee when extracted with the automated method. If we also take a look at matrix effects, and I think that's obviously very important in this field, particularly when you're working with food samples where there could be a significant amount of matrix effects, we again see that overall there was low matrix effects for the coffee and cocoa that was looked at. What you have depicted here is the manual extraction method, which is a modified catcher's method with hydration, which is typically used for samples such as cocoa and coffee that are being explored here. In this particular method, 2 grams of sample were added to 4 mils of water, and then that was allowed to wait for about 30 minutes to really hydrate that sample. And then 10 mils of acetonitrile was added. Shake that for 7 minutes. Add the extraction salts, shake for 7 minutes, and centrifuge for 5 minutes. Add the cleanup materials, and then transfer that supernatant with some formic acid, and then vortex for 30 seconds, and centrifuge for 5 minutes before doing the same workup as far as evaporating down to 50 microliters, dissolving in a GC amenable solvent, and then going to GC analysis and or diluting with 1:4 ratio of water for LC analysis. So this method, again, it's manual, right? The technician is busy doing all of these steps. Also, keep in mind the time here. So 30 minutes, 7 minutes, 7 minutes, 5 minutes starts to add up, okay? It takes some time to do this method. So by bringing automation to the table, we have offered, freeing up that technician to do other things and some better efficiency from a method perspective. But obviously we want to show that the data is better as well, because even if you've got some benefits to automation, if you cannot maintain the data or get better data, then that's not going to be the best option for you. So what I hope you can see from this particular slide is just the details of the manual method, and then in comparison to automation, see some of the benefits that automation brings to the table. If we take a look at the data, what we see is that we're getting a higher percentage of non-detectables, so less in the acceptable range that we would like to see. And then obviously that's what we want to see. When we bring automation to the table, we're bringing some benefits as far as a simple method and freeing up the technician, and there's some things there, but it all comes down to the data in the end, and you want to be able to see that you've got improved data as well. And I think it's just kind of intuitive that if we remove the manual aspect of it, remove human error and so forth, we are going to see better results. And in general, that is what we're seeing for both the coffee and the cocoa. So if we compare these directly, on the left you have the automated extraction results, and on the right you have the manual extraction results, and overall we're getting better recovery for the automated extraction on the edge system than when compared to a catcher's method with hydration for both coffee and cocoa. So again, this is what we want to be able to see, right? Because you get all the benefits of automation, but you also get better efficiency when it comes to the data as well. So one of the things that we wanted to take a little bit of deeper look into was the matrix effects here, because that's kind of another bonus you get when bringing automation to the table, is that overall we are seeing less matrix effects compared to the hydrated catcher's method. So this is depicted here in this just total ion chromatogram for T, and if we dig in a little bit deeper, we'll see that in this particular area here, around 9 to 10 minutes, you can see where there was less matrix effects when using the edge compared to hydrated catchers. And again, this is for a T sample. Now for a cocoa sample, we see very similar effects. Again, in that range now of about 6.5 to 7.5 minutes, you'll see that there was significantly more matrix effects for the hydrated catchers than when compared to the edge method. And obviously, less matrix effects is going to lead to some better results. We can easily see those pesticides in that range compared to when we can't, when they're kind of clouded by the matrix effects. And this phenomenon that we're seeing with better or less matrix effects for when using automated extraction on the edge continues for the coffee sample as well. Again, in a very similar range, it seems to be that 6-minute range tends to be a little bit problematic for these particular samples. And again, we're seeing less matrix effects on the edge compared to hydrated catchers. So there was a consistent trend of seeing more matrix effects for the hydrated catcher's method when compared to the automated edge method. And obviously one of the big differences between those two methods was the hydration step. For the automated method, no hydration was employed. So it was taken a closer look at this, and it was found that with the hydrated method, you get some co-extractables, particularly caffeine and theobromine were noted being extracted during that hydration method, and that's what's leading to these increased matrix effects. So there's just, real reasons behind why hydrating in some cases may not be the best benefits. And in this particular case, doing the hydration method did lead to more matrix effects. So here you have the final extracts represented for both the manual extraction and the automated extraction on the edge system. And one of the big things that you're probably going to note right off the bat is the volume difference. So the manual extraction is done in about 10 mils total, where we're using closer to 30 mils total in the automated extraction system. And that is a difference that needs to be accounted for. But overall, what we're seeing is that by running the samples more dilute, which is what you have for the automated system, is that it's aiding in this less matrix effects. Okay, so with just having a more dilute sample, the matrix effects are not as substantial and you're getting a cleaner chromatogram overall. So that's just another potential benefit of actually running in a more dilute scenario where you do on the automated system compared to the manual extraction. So here were the conclusions from the University of Almeria when they did this study. So, overall, kind of going back to the very beginning, interest in automation has increased over the years. And pressurized fluid extraction has been shown as a viable option for the extraction of pesticides from the samples looked here, particularly coffee and cocoa, where there was no need for that hydration step. So it simplified the method and overall led to better results and less matrix effects. And that, overall, the automated extraction system worked well for coffee, cocoa, tea, and other dry materials. And I think we're talking about dry samples here, but this is also applicable for wet samples. So stay tuned, because that's the kind of like next steps. But I think the University of Almeria recently released some data on olives. Getting exciting on kind of just the expanse of different matrices that we can employ the Edge automated system to. So this specifically kind of hones in on some of the particular advantages to using the Edge pressurized liquid extraction system. So one is sample throughput. So they were able to accomplish 70 samples in an 8-hour time frame. Again, this replaces the tedious manual extraction. No need for cleanup. That was not really the focus of this talk, but I think it's a really good point in the fact that the Edge data did not use cleanup, where the modified catcher's data actually did have some cleanup. Now, you can run cleanup on the Edge automated extraction system. You just put that cleanup material as a layer in the cell and you can do it. But often we're finding that it's not necessary. So those are just components, some complexity you don't have to add. It has the possibility of bubbling. In the methods here, they didn't find a major advantage to bubbling, but you can bubble with nitrogen, and there may be an advantage there. So just another, again, the flexibility, a lot of method development, something that could be explored. And, traceability. So this is one of the things I like to talk about, because there's reporting, there's information back. At any moment in time what pressure and temperature your sample was being exposed to. And again, you've got users you could have different controls over, who ran the sample, when it ran. There's just a lot of traceability when it comes to it. And I think in the modern world, traceability is going to become more and more important, and at some point necessary. So with any study, there is obviously always a need for future work. Kind of our work is never done. And it kind of, obviously we've talked about cocoa and coffee here, but there's other food substances we can go to, fruits and vegetables, and really just even beyond that. The automated extraction system can really be employed to any solid, semi-solid, even liquid to low volumes sample. So it's really kind of sky's the limit on what you want to explore there. And again, the realm of pesticides is extremely large. And so we could be looking at a wider range, particularly maybe some of those really higher polar pesticides, which could be very problematic. And then again, just all the different method development. So again, work is never done. always continues, but I think the material that the University of Almeria presented here was really strong and exciting, and hopefully shows that the EDGE automated extraction system is a good option for the extraction of pesticides from these dry commodities. Again, this is not my presentation, and so I'm just kind of giving my commentary to it, but I want to be justified and show everything, and so they had a reference slide here and use the references, and I think obviously it's good for all of us to know the different references and so forth. So this is available, and here's the information here on the references. And that brings us to a conclusion. So I hope that I've been able to bring my take of these slides to your attention to that. And again, I hope I've left you excited as I was about this particular study. And I look forward to see what more comes out of the University of Almeria. So a huge, huge thank you to them for sharing these slides with me and for allowing me to give my point of view on them. So thank you. And take care.